Hi, I'm Ishneet, and together with Money, our final project introduces Chef, a composed hybrid for extraction and field routing for item level receipt parsing. Bill splitting apps like Splitwise and Venmo still require users to manually type every itemized amount. To fully automate that from an image, we need item level extraction, where each item has a price, and standard receipt benchmarks only test document level fields like the store name and the total. In the document AI literature, there are two compelling paradigms. One is the OCR dependent and one is OCR free models. The question is which one is actually better and can we combine them? Here are two architectures that we compare. On the OCR dependent side, we have layout LMV3, which is a multimodal transformer that consumes Tesseract's OCR input along with the bounding boxes and image patches. And it classifies token with the BIO scheme. On the OCR free side, we have Donut, which is a Swin transformer encoder feeding a BART autoregressive decoder that generates structured JSON directly with no OCR step at all. The fundamental difference is that the layout LMV3 labels tokens and the Donut generates them. As we'll see, that distinguish is what determines which model wins at which subtask. For layout LMV3, we have fine-tuned Microsoft's pre-trained checkpoint with Adam W with these parameters. During development, we identified a labeling convention for is key flag that significantly affected the aggregate field accuracy. For Donut, we have used the Naver's publicly released fine-tuned checkpoint. As we were trying to train it, our attempts to fine-tune it on a MacBook Air and Collab both ran out of memory. Once both of these base models are working, we propose Chef, items routed to layout LMV3 and aggregates routed to Donut.
So for our results, we use Cord's test set of 100 receipts with normalized F1 as our metric. And as Ishneet mentioned, layout LMV3 and Donut are both good at different things. So we see here that in single item fields like menus, name, price, and count, LMV3 beats Donut. And for aggregate fields like subtotal price and total price, we have Donut beating LMV3. And we propose Chef, which is our hybrid methodology, which combines both of these for a better F1 and line item score than both. Um, we do a few ablations to make our result more rigorous. The first ablation is running LMV3 alone and Donut alone, and then our Chef hybrid system, which has a better F1 score than both of them. We also want to show that the routing direction matters. So we reverse our routing direction in that we take what Donut is good at and make LM3 generate that. And we see that the F1 score there is worse than both LMV3 and Donut. We also do an ablation study with and without the ski filter, and we find that having the ski filter drives up our score by a lot. Our final ablation is for the OCR standard, which is used, and the OCR standard used by CORD, which is the gold OCR standard, which is human annotated, makes a huge difference in terms of the line item matching. Our conclusions here is that receipt parsing is a composite task wherein different subtasks have different biases. We also see that our hybrid system is principled in that the direction of the matching also matters, and it's not just the presence of the system which makes it better. We also find out from our OCR ablation that standard chord scores are overstating the performance of the model just because the OCR is of a better standard. Thank you so much.